Hello everyone, welcome to bonus number 2, how to use MMC modifier or LMC modifier properly based on the function. Since we have learned the MMC and LMC modifier, so in this module, we're going to learn in which application that we should select those two modifiers. First, these two parts will be assembled together, and we need to figure out if for this position tolerance, should we use circle N or should we use LMC modifier or should we use nothing here, right? So first, the first application is after these two parts assembled together, we need to put a pin inside. So the function is assembly of this pin with this sub-assembly, right? So in this situation, if assembly is the function, then it's easy to imagine if the hole size is smaller, for assembly, it's the reverse situation, right? So the position tolerance should be smaller or without bonus. Again, if the hole is smaller, there shouldn't be any bonus. If the hole size is bigger, then even the position is deviated further, the function of assembly is still okay. So that in that case, we need to add bonus if the hole size increased. So that's why we put MMC modifier here. That means if the hole size is smaller, 1.8 is smallest size. So don't forget, smallest size for the hole is the MMC modifier. And in that situation, the bonus is 0. The total position will be 0.4. If the hole size is 2.0, that means the size is increased. Then there's going to be a bonus tolerance here. It's 0.2, right? And then we add them together, we will get 0.6 value. The next one, if the hole size is the biggest one, 2.2, then it's much easier for assembly. Then we have maximum bonus here. The total position will be 0.8, right? So that's the function of this MMC modifier. Next, application number 2. In this application, the function is we need to control or guarantee the minimum distance between the edge of the big hole and the edge of the small hole. Or that way, from this edge to this edge, we should guarantee there's a minimum distance, right? Or from here, that at least we can see some material. If you look from top down, there at least some material here, right? So in other words, the distance between this edge and this edge should be controlled, the minimum distance. In that situation, if the hole size is bigger, then the distance is worse, right? It's smaller. So the hole size is bigger, then the position shouldn't have any bonus, right? Because the distance is worse. If the hole size is smaller, then there's more distance here. In that situation, the position of this small hole is allowed to deviate it further, right? So let's put it here. If the hole size is bigger, then there's no bonus, right? And if the hole size is smaller, then you are allowed bonus. The position is allowed to deviate it further. However, the minimum distance is still guaranteed, right? If the hole size is the smallest hole, 1.8, then we have the biggest bonus here, right? So total position tolerance will be 0.8. So if you have interest, you can calculate it out, the smallest distance using different hole size from 2.2 to 2.0 to 1.8, but the position tolerance use this one, right? You will find it out. You can get the same minimum distance here. All right, this is the second application. Let's refresh your mind. The first application is for assembly. So that's why we use MMC modifier. For second application, the function is the minimum distance or minimum material here. You can see. This is the second one. The last one is we need to control the position, the fixed position, or we need to guarantee the alignment between the big hole and the small hole. Or sometimes we call this coaxiality, that this big hole and small hole should be aligned, should be coaxial to each other. So in that situation, we don't want to increase the position, right? Because if you increase the position of this hole, then the coaxiality will be worse, or there's more misalignment. So in that situation, we shouldn't use any modifier here, right? So put nothing here. In old standard of ASME, there's a S circled, but this S circled is obsolete, right? We shouldn't use this one anymore. Even you put S circle here, it means nothing, right? Because S circle means regardless of feature size. That means it doesn't matter how big of this feature size or how small of this feature size, this position is always 0.4, right? So if the function is for the fixed position or for the coaxiality or for alignment, in that situation, we put nothing here. No modifier should be used here, right? So that's why you can see here, the size is changed, but position is exactly the same. All right. So let's have a quick review. Which modifier should be used? It's all decided by the function, not decided by production or by inspection, right? All right. Thanks for watching. See you in the next bonus videos.